Welcome viewers. In this video we are going to discuss about the security and safety load combinations for 220 kV double circuit transmission line tower structure loadings as per IS 802. Before going to watch this video, we request you to watch our previous video which are in 5 stages. In the first stages we had to discuss about the electromechanical input required for the transmission line tower design. In the second stage it is a reliability level and wind load calculation. In the third stage, we had to discuss about various classification of loads in terms of reliability, security and safety. And in the fourth one, we had to discuss about the temperature, snow and sag tension calculations. And this is a sixth stage. In the fifth stage, we had to discuss about the reliability load combinations. So in this sixth stage, we can discuss about the security and safety load combinations. Let me go in detail about this discussion. Similar like to reliability load cases, we are going to calculate 3 directional loads here: longitudinal loads, transverse loads and vertical loads, FFX, FFY and FFZ respectively. This is as per class 12.3.2 of IS 802 part 1 section 1. So here are the cases. In longitudinal loads we need to check if the tower which we are going to design is a suspension tower, then we need to consider the mechanical tension as 50% for conductor and 100% for earth wire at everyday temperature and no wind. Next to that angle or tension tower, the mechanical tension shall be 100% of design wind at everyday temperature or 36% of design wind at minimum temperature, whichever is greater. This is applicable only for broken wire. There should not be any forces to be considered in case of intact wires. So when we are looking into the dead-end tower, it is entirely reverse than the angle or tension tower. Whereas here, for mechanical tension, we need to consider nothing for a broken wire, and for intact wires, we need to consider 100% of design wind tension at everyday temperature or 36% of design wind at minimum temperature, whichever is greater. So this is reverse to the angle or tension tower. So next is transverse loads, FY. In that there are two conditions. In case of suspension tower, no wind should be considered. For example, wind on tower, wind on conductor, wind on ground wire or earth wire, wind on insulator strings should not be considered. And the mechanical tension we need to consider according to the deviation of the conductor. So for that 50% of the conductor and 100% of earth wire at everyday temperature and no wind condition to be considered. When coming to that angle, tension and dead-end tower, wind load on towers, conductors, ground wire, insulator strings, all the wind load should be considered, but 60% of the wind span for a broken wire and 100% of wind span for other intact span to be considered. And for mechanical tension, we need to consider 100% of deviated conductor tension with design wind and at everyday temperature or 36% of design wind at minimum temperature, whichever is greater. So this is what the transverse load we need to calculate as per class 12.1.2 of IS 802 part 1 section 1. Next one is vertical load, FFZ. This is as per class 12.2.2. This is very simple. In this we are going to consider only the self height of the tower, conductor, earth wire, insulator strings and accessories. So we are going to consider all the self height of the components, but only for the conductor and earth wire we need to consider 60% of weighted span in case of broken wire. So for weight of conductor, earth wire, insulator string and accessories we are going to calculate manually. But for self height of tower, it should be done using the modeled software. So quickly we will look into that Excel calculation for all these 3 directional loads. So this is an Excel sheet which we are going to discuss about how to calculate the security load combinations. So here we can consider right now horizontal and vertical deviation is 0 degrees. And for type of tower, start from the beginning we are doing this calculation for suspension tower. So for suspension tower we can check this table. So it is stating that mechanical tension to be considered as 50% of conductor and 100% of earth wire at everyday temperature and no wind condition. So here if you see that tension calculation for conductor, you can see here for everyday temperature 32 degrees Celsius and no wind cases, we are having 2236 kg. So in that we need to consider 50%. So it is 1118. So that multiplied by cos 0 vertical, cos 0 horizontal remains same. So next one is for earth wire we need to consider 100% of tension. So if we see that tension calculation for earth wire for everyday temperature 32 degrees Celsius with no wind, it is 481 kg. By multiplying cos 0 we are having the value 481. So coming to the transverse load, for suspension tower we should not consider any wind loads. However, mechanical tension can be considered with 50% of the value in case of conductor, and for earth wire it is 100%. At everyday temperature no wind to be considered, similar like which we had calculated in a longitudinal load. Only thing here the sin theta for horizontal angle to be applied instead of cos theta where we had applied here. As we are having both vertical and horizontal deviation as 0, the value in transverse load becomes 0 here. And vertical loads, if we are talking about the vertical loads, vertical load is common case for all the type of tower, suspension, tension tower and dead end tower. So that self weight of the tower we are going to consider as per model. We are going to apply directly to the model self weight. And for wind weight of conductor, we need to consider 60% in case of broken wire. So we are multiplying with this 0.6, so that we are getting 293 kg. Similar for earth wire it is 77 kg. And for remaining tension insulator and suspension insulator we are just taking their weight. There is no reduction in that for security load combinations. So these are the load parameters we need to consider for suspension tower. So let me check how we can consider for tension towers. So I am changing here to be a large angle tower or large tension tower. So if you see here in the security combination, so as per the table, as per the class 12.3.2, it is stating that mechanical tension to be 100% design wind at everyday temperature or 36% design wind at minimum temperature. Only for broken wire condition we need to consider. For normal condition it is the value is nil, so 0. So we had applied here 0. So for here a broken wire condition we need to consider whichever is greater in this. So we can see here from the table for conductor tension, this one minimum temperature with 36% of wind speed is having 6725 kg. So that is what we are going to apply here. So again here also there is no deviation, so the same value should become here. Similar case for earth wire also we need to consider here. We can find here the tension calculation which we got done for earth wire. It is 2957. So this value we need to consider here. So coming to that transverse load, this is applicable for both tension and dead end tower, whereas we need to consider wind as per which we got calculated in reliability level cases, and but for broken wire condition we need to multiply with 0.6, that is 60% of wind span we need to consider. So this is applied to earth wire also. So remaining thing we need to calculate same as earlier for reliability level. And here also you can see that 100% tension we need to consider for angle and dead end tower. So in that again, if there is a deviation, we need to apply those deviation, so that we will be getting the transverse load in that case. So next one, if you are coming to vertical load, it is the same for all the type of towers, so we no need to discuss again. So now what we are going to do is we need to apply this deviation. So before going to apply for the conductor deviation, I think we had missed out one more thing. So we can also check instead of a large angle tower, what if it is a dead end tower? So as per this class 12.3.2, for dead end tower, it is a reverse of a tension tower. So here that mechanical tension we should not consider for broken wire condition. So here it is 0, and for normal intact wires we need to consider 100% design wind at everyday temperature or 36% design wind at minimum temperature. So it is reverse of angle tension. So in angle tension tower we used to consider, broken wire case we used to consider this 6725, but in this dead end case we need to consider this tension value in normal condition. So similar case is applicable for earth wire also, and the remaining things are same for transverse loads. Both tension and dead end tower are same, and also for vertical load it is same. So now we will move to how to calculate the deviation in case of security combinations. So I am just copy paste this calculation and placing before security safety combinations. So here we can edit this as with the deviation. So for dead end tower, we can consider that suspension tower first, which we are doing the calculation start from the beginning. So suspension tower we can apply some 5 degree here. So this will directly getting reduce that longitudinal loads because of that deviation. So of course we can able to see some loads in transverse sides due to the deviation, and vertical load remains same. So in case of again the large tension towers, if you see large angle tension towers, so with deviation you can go up to 30 degree to 60 degree, whatever it may be. So entire thing is getting changed. So here you can see some more amount of value in transverse side in case of large angle towers. So likewise this calculation is adaptable for all kind of towers. If in case of dead end tower, so with the conductor deviation, say for example 10 degree, both vertical and horizontal, you can see here the value. So this is all applied for all the type of towers with some various loop conditions, if conditions. So let me start with the next category of load combinations called safety. So when looking into the safety classes, this is applicable as per class 13.3 of IS 802 part 1 section 1. In that for longitudinal load we need to refer class 12.3.3. In this there are 3 categories of load calculation method according to that type of tower. One is for suspension tower, mechanical tension we need to consider for broken wire alone. For that we need to consider the direct value. Say for example for conductor it is a 10 kilonewton and for earth wire it is 5 kilonewton. And coming to the tension or angle tower, mechanical tension to be considered like broken wire type we need to consider wire under stinging to be considered as 2 into 50% of mechanical tension, and for intact wires it should be 1.5 times the mechanical tension at everyday temperature and no wind cases. Coming to that dead end tower, normal condition we need to consider for 100% of conductor and earth wire at everyday temperature, no wind. Force due to unequal span can be neglected in this case. So next we are seeing the transverse loads in Fy, y direction. So in this we need to refer class 12.1.3. Here we need to consider, so this is applicable for all the type of towers, suspension, tension and dead end towers. So here that mechanical tension for deviation only we need to consider 100% for conductor and earth wire at everyday temperature and no wind cases. For both the normal condition and broken wire condition we need to consider, and here also no need to consider wind loads as like in suspension tower in security cases. For the vertical loads we need to refer two classes 12.2.2 and 12.2.3. As per this class, these are the method of calculation. So we need to multiply this class 12.2.2 of 1 with a multiplication factor of 2. In this we need to consider weighted span for broken wire condition is 60%. So applying this we need to consider that weight of conductor for broken wire condition, and as per class 12.2.2 of 2 self weight of the tower. So this anyhow we are going to do it in modeling stage, and in that class 12.2.3 of 2 directly we need to consider 1.5 kilonewton at each cross arm, assuming that it is a weight of lineman with tools. And the next one is 12.2.3 of 3, in that 3.5 kilonewton at the tip of cross arm to be considered up to transmission line voltage of 220 kV, and equal to or more than 400 kV we need to consider 5 kilonewton at the tip of every cross arms. And as per class 12.2.3 of 4, for voltage level which are greater than or equal to 400 kV, in case of a double bundle conductor we must consider 10 kilonewton at 600 mm from the tip of cross arm. In case of a multiple bundle conductor we need to consider 20 kilonewton at 1 meter from tip of cross arm. This is one at the last for bracing and redundant members which are having a less than or equal to 15 degree with respect to the horizontal line or plane. We must consider 1.5 kilonewton vertically acting at the center of the member. So these are the vertical loads we need to consider for safety load cases. So let we look into that Excel calculation for more understanding. So similar like which we had calculated for security combinations, we can consider initially 0 degree for both horizontal and vertical. So again here we are considering the suspension tower first. So we can look into that class 12.3.3 for longitudinal loads under safety combinations. So here you can see that mechanical tension we need to consider for broken wire condition. So direct value 10 kilonewton and 5 kilonewton for earth wire we need to consider. So here for broken wire condition, so 10 kilonewton is converted into kg. So that is 10 multiplied by 1000 divided by 9.81. So we are getting 1020 kg. Similar like for broken wire condition we are taking 5 kN, converting that it is coming 510 kg. 5 into 1000 divided by 9.81. So this is for longitudinal loads to suspension towers. Next, if you are coming to transverse loads, so here the transverse load is common for all the type of tower, say for example suspension, tension and dead end tower. So here that mechanical tension we need to consider for deviation cases 100% of conductor and earth wire at everyday temperature and no wind for both normal case and broken wire condition. So for both the normal condition and broken wire cases the value remains same. So we are considering the deviation here as 0 degree, but for conductor and earth wire tension is as per everyday temperature, no wind cases. So you can see here in the tension calculation which we had done earlier. So 32 degrees Celsius is our everyday temperature. In that no wind cases we are having 2236 kg. Similar like for earth wire it is 481. The same we are considering here. As there is no deviation, the value becomes 0. And as we discussed just before, vertical loads is a combination of these classes. So in that first class we need to multiply with 2. So here we had done this. For normal condition we can consider same as weight of conductor, and here in the broken wire condition we are multiplying by 0.6 as we need to consider weighted span as 60% and multiplying with 2 as per this class. So similar case we are applying for broken wire condition also. So we are getting these are the values. Remaining tension insulator, suspension insulator and weight of structure are remain same. Addition to that, the classes are talking about that 1.5 kilonewton we need to consider for a lineman with kit. So it is 1.5 into 1000 divided by 9.81, we are getting 153 kg. It is a conversion formula. And the loads at the tip at the cross beam. So we had considered here as a 220 kV. So suppose in case if we are having 400 kV, let we see what it will come. So 400 kV you can see it is 5 kN, and also for 400 kV if it is a twin bundle conductor we need to consider 10 kilonewton, but as per this our input mechanical input data we are having only the single. If we are changing this into twin, then we can see here for twin bundle we need to apply at 600 mm from the tip of cross arm. The value should be 1.5 kN, which is equal to 1020 kg. Suppose if I am selecting the bundle like quad, which is more than 2, so you can see here 20 kN, 2039 kg at 1000 mm from the tip of cross arm should be considered. So this is applicable only for voltage level which is equivalent or more than 400 kV. So for our case, for 220 kV, this is not applicable. This last certain things. This one is not applicable in case of 220 kV. And next one is bracing and redundant member. If it is having less than or equal to 15 degree, then we need to consider 1.5 kN, which are equal to 153 kg. So for tension and suspension insulator, in case of safety load combination, we need to multiply this tension and suspension insulator also with factor 2, as which is described here in this class. So next we will check with angle or tension towers. So we can consider large angle tower. So in this case we need to consider as a broken wire for wire under stringing is 2 into 50%. So it is nearly 100%. So 2 into 100% of mechanical tension. I think we need to change this. As per our calculation, we used to have only single phase. So just we did some trial for that. So we can change that to single. So now you can see it is for everyday temperature, no wind cases. If we are looking into that conductor tension calculation, so everyday temperature is 32 degrees Celsius, no wind cases, it is 2236. So for broken wire condition, it should be considered 2 into 50%. So it is nearly equal to our 2236. But in case of intact normal wires, we need to multiply this with 1.5. So this 2236 is multiplied with 1.5. We are getting 3354. So this is the value, and as there is no deviation, we are getting the same value. Similarly, like in case of earth wire also, we need to consider like this normal condition, we need to consider 1.5 times mechanical deviation, and for broken wire condition it is 2 into 50%. So we can see here everyday temperature, no wind, no ice, it is 481 kg. So we are considering the same value here. Only normal tension we need to multiply it with 1.5 as described in this class 12.3.3 for tension and angle tower. For transverse load and vertical loads are remain same for all the type of towers. There is no change in that. Now let we check for what is a dead-end tower. So I am changing here dead-end tower from the drop-down list. So here you can see that a dead-end tower normal condition we need to consider as 100% of conductor and earth wire at everyday temperature and no wind cases. So we already calculated this conductor tension and earth wire tension. Everyday temperature it is again it is 2236 kg for conductor, and for earth wire it is 481 kg. So same thing we are applying here. So only difference between here tension and dead-end tower is here we are not going to consider any broken wire condition, only the normal condition we are going to consider, that too with 100% of tension value. Instead of here it is 1.5 tension, 1.5 mechanical tension we had considered. Here it is for a dead-end case it is only 100% normal tension we need to consider. So again here the transverse and vertical load remains same. Now we can do this for combination with the deviation gantries. So we can do copy and paste. You can place this sheet before here, and I'm just editing by deleting this no, so that it is applicable for deviation, conductor deviation calculation. So here we can consider whatever we want. So for suspension tower we always used to consider the deviation less than 5 degree. So we can have this by entering here. Anyway, the broken wire condition for suspension tower remains same, 10 kN, 5 kN we need to consider. Only for transverse load we are going to consider this deviation consideration as per this transverse load calculation. mentioned in the class 12.1.3. So in this we need to consider 100% of conductor and earth wire tensions at everyday temperature and no wind for both broken wire condition and normal tension. So but in case of large tension tower, there is a significant variations in terms of transverse loads. Say for example, this I can consider 30° for both vertical and horizontal deviation, so that you can see here it is 969 kg and some longitudinal force get reduced due to the deviation. So this is all about our various calculation method for safety, reliability, security cases. So with this we can close this, we can end this video, and in the next video we will be discussing about the load trees with all these cases, reliability, security and safety cases. Thank you for watching. Look at description for more related video. Subscribe to this channel for more updates. Thank you.